You to have me. Thank you for having me today for this presentation or introduction about electric motor bearings with shaft grounding ring. In this case, the AEGIS ring. So my name is Asim Awan. I'm the industrial sales manager for Southwest Europe, and also in charge recently from the Middle East and North of Africa. Today, the topics I'm going to develop will be the root causes of shaft voltage. What does it mean to have a shaft voltage, and what is the impact on the bearings? What possibilities to prove has been imagined to mitigate this issue? The mitigation strategy for sure, and presentation of the AEGIS shaft grounding ring, and also to show you and elaborate more about the idealistic case where you have the best possible electrical ground system. I'm going to elaborate more about the best practices, which is also available in our handbook, and some application examples in wide and different sectors. So today, it's not something that it is hide, but we have more and more need of VFDs, so variable frequency drive, because of its features. The features are really simple. We can see many advantages using the VFDs today with the motor coupled. Precisely adjust the speed and the torque of the motor. You only consume what you need, so energy savings around 20 to 50%. Process optimization for sure, and you increase your productivity. To give you some figures, by 2030, from BMAS and ESA association, we are going to consume 50% more VFDs in the market. And why? I've just explained that you can control the speed and the motor and also the torque. But by doing this, you are going to cause two kinds of failures. The first one will be the winding failure. And the winding failure is something that I will not elaborate more because it can be solved with a class of insulation. The second one is something that we are going to study a little bit more, which is the bearing failures. Today in Europe, this is very important. We don't have any standards, regulations, or general recommendations from the OEM. So we don't know that much how to deal with this issue, whether it's to place an insulated bearings, two insulated bearings, insulate the whole motor frame. So I will dig a little bit more into that and to explain how to deal with the solution if you don't identify clearly the root causes of the issue. So two bearing currents that you need to understand that are mainly affecting your system, and especially the bearings when you have a motor driven by VFD. The first one will be the EDM current. The EDM current, EDM standing for electrical discharge machining. It's a current that is coming from the inverter, because inside you have a transistor which is switching frequencies very fast. And by doing this, it's coming with a capacitively coupled shaft voltage. And this voltage wants to go through the bearing to the ground, because the bearings are the way of least impedance. This is why very important to identify this EDM current to know what is its purpose. Its purpose is to go to the ground, which is different from the second current. The second current is a high frequency circulating current. And from what his name means, it means circulating current, circulating between the rotor and the stator. So because of high frequency flux produced by common mode currents, these currents can damage both bearings, and it's starting from 75 kilowatt motor power. So when you have a motor driven by VFD, starting for the first kilowatt of the motor, is here, it's 0.75 kilowatt, you will still have this yellow current. Let's say yellow, I want to make things simple. Because this yellow current, which is the capacitive EDM currents, remember, coming from the VFD, he wants to turn down and go to the ground again, because he wants to come back to the inverter. And the way of least impedance, because we know that the current is really lazy, he wants to find a spot. I'm sorry. He wants to find a spot where it has a least impedance, where he can discharge and go directly to the ground. This is why when you have a motor driven by VFD, for the first kilowatt of the motor up to 75 kilowatt of the motor, you just need something to mitigate this yellow current. And starting from 75 kilowatt motor power, you will have in every motor this high frequency circulating current. Remember, circulating between the rotor and the stator. And this one is evolving on the winding between the rotor and the stator and trying also to discharge through the way of least impedance. And in this case, the bearings. This current is going to bring up the voltage on the shaft. And this is this voltage that we are focusing on to reduce as much as possible in order to not affect your system anymore. And to give you the idea behind this, let's take an example. One step back. When we have a simple motor, no VFDs, asynchronous motor, it's this one, you see, you will have the common mode voltage, which is the sum of the three phases, which will always be equal to 0 volts. We can see here, if we take 1, you see, minus 0.5, minus 0.5, 0. Every single step is going to be 0. So it's going to be balanced. We say that the common mode voltage is balanced because always equal to 0 volt. It means the bearing protection is generally not needed, except for large frame motors. And I will develop more in the further presentation. On the other hand, when we have a motor driven by a VFD, a variable frequency drive, that is controlling the speed and the torque of the motor, remember, it has inside an IGBT transistor, which is switching frequencies very, very fast. And by switching frequencies to control the speed of the motor, it will induce some pulses. And those pulses we call pulse width modulation. They are never regular. And it's trying to simulate a sinus wave very smoothly by these pulses, which are irregular. And by doing this, the common mode voltage is never positive, 0, or negative. It's either positive, either 0, either negative. This is why in this kind of cases and example, we say the common mode voltage always unequal to 0. We call this a 6-step waveform. And this is why we say, because of this unbalanced common mode voltage, bearing protection is needed. And what do we mean by bearing protection? We say from the yellow current, remember the capacitive EDM current, which is induced on the shaft voltage discharged through the motor bearings, we need something to guide this yellow current to the ground. And this is where our AEGIS ring is operating. Because by placing the AEGIS ring, which is a ring with 360 degrees contact fibers, more than 100,000 contact points of fibers, which have a thickness of 0.76 millimeter, it will take this yellow current because of high conductivity of the fibers directly to the ground. It will go on the fibers first, then on the aluminum body, then on the cast of the motor, and then directly to the ground. Very important. As we are dealing with high frequencies, it is highly recommended to install a high frequency grounding strap which has a flat surface, because we know high frequencies, electrons, currents, high frequency like to travel through surface because of skin effect. So from the first kilowatt of the motor up to 75 kilowatt of the motor, you only need an AEGIS ring to place on the drive end or the non-drive end, depending on the configuration of the application. And then when you ground the motor shaft, you need to understand that the motor is working as a capacitor. What does it mean? When it's working as a capacitor, it will discharge. Charge in the first place on the stator, then the rotor, then the shaft, and trying to find a spot, a place of least impedance to discharge. And in this case, it's going to be the bearings. This is why sometimes some customers just place 2 insulated bearings. You see, 2 insulated bearings. But this yellow current is capacitive. And this is why sometimes you can have cases where you have a bearing, and you see when you cut the bearing and it's insulated, you still see the inner race, which is attacked by EDM current. Because as a capacitor, it can charge on the insulated part and then discharge on the other way. If you understand very well how to deal with the yellow current, it's just placing the AEGIS ring. from the first kilowatt of the motor up to 75. Then starting from 75 kilowatt, you will start having the high frequency circulating current. And you see this node is not linear, it's more exponential. This is why to mitigate it, or to cut it, you just need to cut the circuit. You see, it's a closed circuit evolving between the rotor and the stator. And by placing an insulation, in this case, we recommend to install an insulated bearing, you're gonna have the circuit which is cut. Then you don't have any more high frequency circulating current that will build up into your motor frame. So the solution complete will be for the yellow current an AEGIS ring, and starting from 75 kilowatt motor power, AEGIS ring on the drive end and insulated bearing at the opposite on the non-drive end. Same, if you install the AEGIS ring because of the configuration which is specific from the application, here on the non-drive end, you will have to install the insulated bearing on the drive end. It has to be opposite for considering equipotential purpose and consideration. So the impact on the bearings, when you have this voltage, which building so much energy, it will manage to outpass the dielectric properties of the bearings, you see? And to melt metal, you need around 1200 degrees. It's very big energy, and it's related to the bearing capacitance, which is the bearings, insulation, and the shaft voltage. But the shaft voltage is really important because more you reduce it, less energy you will have to discharge through the bearing race. This is why we say when you have a shaft grounding ring, you will be prevented for electrical discharge through your bearing race. And we propose this 2-year warranty, which is very important because we know we can rely on our solution, on the AEGIS ring, as it's a device that is having 200,000 hours operating. It's around more than 20 years. So you see, once it finds a spot, these pits to occur, you see, this is how it looks. You melt metal to metal, and you will have some small particles, metallic particles, that will mix up with the grease, and the grease will be contaminated, and you're gonna have a blackened grease and also burnt. And this is where you can identify whether you have a current problem, electrical discharge problem, by cutting your bearing, seeing the inner race, or by analyzing the quality of the grease. If you have something which is black and burnt grease, it means you have electrical discharge occurring. And you see how it looks? EDM pits, which is zoomed more than 1,000 times. And you can see how it looks. This is a phenomenon. As a phenomenon, it appears 3 to 12 months of the operating of the motor. So in the first place, when you have a motor driven by VFD, if the phenomenon occurs because of so many factors, but mostly because of the inverter, you're gonna firstly notice the frosted bearing race, which is like this. It is frosted because when you cut the bearings, when it's new, you can see inside like in a mirror. It's like a mirror. But when it's frosted, it's like matte. And it's very difficult to see yourself in it. So the first step will be a frosted bearing race. And more you let it occurs, because once it managed to discharge, we are talking about 1 million discharge per hour. You're gonna have a fluted outer bearing race. And you see, it looks nearly like it's mechanical, but it's not. It's electrical discharge. I don't know if you are very familiar with this picture, but we have a meeting 4 years ago with Nidec Laura Sommer, motor OEM, and one of the maintenance person noticed this phenomenon and said this could be mechanical. And we have a lot of meetings explaining that this is not mechanical. This is coming from electrical discharge, so electricity. And also the second factor will be the burn and black grease. This is something that you can smell and you can see. I don't know if you can notice on the picture, it was green at the beginning, and then it became black and burnt. Because usually when you have a new bearings, you have, this kind of color from FAG, Schaeffler, or SKF. Could be blue, yellow, or green. Yeah, at the end, could be black. It's very, I would say, difficult to identify when you have a black grease. This is mostly used in a very hot country like in the Middle East. Black grease for a heavy application, and because of temperature consideration, the grease has to be black. So you see the impact on the bearings. when bearing fails, it's very important to cut and inspect to know whether you have this electrical discharge problem, which will go into fluting. So this is the ISA standard saying and stipulating bearings should be inspected for failure modes such as spalling, contamination, threading, fluting, and scoring. Very important to identify if you have this issue or not. Remember, the energy that you need is related on the bearing capacitance, but also the shaft voltage. And you see, it's square. This is why we focus more on the shaft voltage than the bearing capacitance. Because when you're changing the grease, you are acting upon this factor. But this factor is more important because it's square. And what we say, we have to be less than 5 volt peak to peak to be in the safe zone. Between 5 to 10 volt peak to peak, it's becoming serious. You have to reconsider your grounding. And more than 10 volt peak to peak, it's very dangerous. Be careful. You will sooner or later face a production downtime. So to identify your shaft voltage, we propose an oscilloscope with a minimum bandwidth of 100 megahertz. Why? Because it's going to be fast enough to see the discharge occurring. And this is what we are proposing. If you have your own oscilloscope, please feel free to use it. And you only need to have the BNC connector here with the probe, our probe with the fibers and measuring dynamically the shaft voltage. And how to see this? When you place the probe on the shaft turning, you will first notice the common mode voltage, which is unbalanced. Remember the 6-step waveform. And then if you wait sometimes, you will see some low amplitude voltage discharge pattern. This is how it looks. And when you increase the time by division, 50 microseconds to 10 microseconds, this is a discharge, you see. 33.6 volt peak to peak is charging and then discharge. This is a discharge, and it can be positive, but also negative. So you see, to measure the shaft voltage, you need to place a probe on the shaft turning, and then you can measure some voltage and also discharge if you're not protected. And also some way to see whether our solution is working or not, we are proposing an AEGIS grounding simulator, which is a segment of our ring. You can see the fibers that are coming out from this device. And by placing it on the shaft, while measuring the shaft voltage, you will see that the grounding simulator is taking the current away from the bearing race, and you see the voltage is dropping from 28.6 volt peak to peak to 2.2 volt peak to peak, thanks to the simulator. So it's also a way to show to the end user that the AEGIS ring is bringing the shaft voltage very low. That is not affecting the system anymore. I'm sorry. So mitigation strategies, you have insulation the shaft from the motor frame. We know about the carbon block brush technology, which has more than 100 years and is working very well for DC application, DC motors and low frequencies. But you need maintenance to change it quite often. The difference with the AEGIS shaft grounding ring technology, it's the maintenance-free device that you need to place it. And once the fibers are prevented to any contamination and contaminants, grease, oil, whatever, it will last 200,000 hours operating. Maybe sometimes people have this question, does it affect the motor potential or capabilities? This is really thin fibers, and we have what we call nano gap technology, which means with or without touching the shaft, it will work because of the high conductive fibers. And the AEGIS ring is maintenance-free, meaning that it can operate 200,000 hours, and for 10,000 hours operating, you only have a loss wear around 0.025 millimeter, which is ridiculous. So this is the solution that you have with the AEGIS ring, so split version, and also solid application, press fit application. And I will show you more in a few slides. So remember, you see, specially designed microfibers to flex without breaking because you have ultra low friction. And it's a patented fiber lock channel that secures and protects the fibers here and places the fibers all over the shaft for a 360 degrees contact, permanent. So without AEGIS ring, you can build the voltage going up to 20 volt peak to peak, which is dangerous. With the AEGIS ring, you remain very, very low, 3.6 volt peak to peak. Very important, the AEGIS ring is a grounding ring, so it's grounding the motor shaft, but then you need to guide this yellow current to the ground. This is why you need the high frequency grounding strap. Remember, for high frequencies, because of skin effect, they have the tendency to travel through the surface. So you need to provide this system a flat surface. So the perfect electrical ground system for motor below 75 kilowatts, you need to install high frequency grounding strap everywhere because we are dealing with high frequencies. And you see, installing the AEGIS ring not very far from the high frequency grounding strap. Do not allow the yellow current to travel someplace you don't want them to travel. So then you see, the more nearest is the best way possible. I don't say that if you install the high frequency grounding strap on the other way, it will not work. It will, but this is a perfect electrical ground system to allow you to have a perfect shaft voltage, which is really low and will not affect your system. Same with the driving equipment and the VFD to have a balance between potential. So all I'm presenting today is available in our website, est-aegis.com, on the bearing protection handbook. So below 75 kilowatt, remember, yellow current, capacitive EDM current, you need to guide it to the ground. So you only need the AEGIS ring with a 360 degrees microfibers, highly conductive, that is taking this yellow current away from the bearing race directly to the ground, thanks to the high frequency grounding strap. On the other hand, for a motor above 75 kilowatt, you have two currents, the yellow one and the red one. The yellow one will be dealt by the AEGIS ring. You can have an external installation, but also internal installation, like here, you see, in the shaft cover. So you have the AEGIS ring that is taking away this yellow current directly to the ground. And then on the opposite, you're gonna have the insulated bearing that is cutting the high frequency circulating current between the rotor and the stator. And then when you go above 375 kilowatts, you will propose the Pro Series. What is the difference between the AEGIS SGR standard ring and the Pro Series? It will be the fibers. From below 375 kilowatt, you need SGR rings, those 2 raw fibers. Above 375 kilowatt, you will need 6 raw fibers. Bigger shaft, more current, more fibers. And also a ring that we are proposing in a lot of application areas, such as IC and DC motors, remember large frame motors, and also generators and turbo alternator. We can propose also a universal bracket kit to install it on the motor frame at your convenience. And we highly recommend, especially for pro ring application, to install it with the CS015 colloidal silver paint, which is a shaft coating that is enhancing the shaft surface conductivity, but also prevent the shaft surface from corrosion. Normally, all AEGIS applications should have it. We only recommend today to have it on the Pro Series. This is why for all Pro Series ring project, we offer the CS015 free of charge. Not for SGR. For SGR is different. So, to have a proper tool to identify whether you have a EDM current issue or not, you need to equip yourself with an oscilloscope. If you have yours, that's perfect. You only need to get the BNC connector with the shaft probe. But if you don't have, we can propose our solution with the oscilloscope. So very important, new bearings must be installed with AEGIS shaft grounding ring for traceability purposes. So motor up to 75 kilowatt, you need the SGR rings, AEGIS, on the drive end or the non-drive end. Remember, 2 raw fibers. Above 75 kilowatt, 75 kilowatt, up to 375 or 350, we have this this gap where we can discuss. But normally, I go up to 375 kilowatt. You can place the SGR ring with with the insulation, bearing insulation on the non-drive end. And above 375 kilowatt, 350 in this case, you're gonna have the Pro Series with 6 raw fibers plus a bearing insulation on the opposite. How to install AEGIS shaft grounding rings? We have a lot of solutions we can supply whether it's on site, on the customer side, or also internally. And yes, this is the mounting option we propose today for standard application. You have clamp on, available in solid and split version to avoid yourself to disassemble the whole coupling. Bolt through application to directly drill the motor. Sometimes for warranty purposes, you can do this. So we can advise you to use conductive epoxy, which is gluing the AEGIS ring, available in solid and split version. And the press fit application, mostly used from OEM, but also traction motor engineering department, where they are building a cover to place the press fit application. And one that I really liked is the U-kit, because of the universal kit that we are proposing. You can install whatever application you're facing. If you have a shoulder or whatever, you can still install the AEGIS ring thanks to the universal kit. We call them U-kit. For the Pro series, you're gonna have the possibility to have external installation, same as the SGR, also internal installation. So this is a Pro SL ring, which is the first level of Pro SL application. Then you have the Pro SLR with O-rings features that is part of your ring, which are preventing from the fibers to be they are prevented for powder, dirt, liquids, lubricants, but other contaminants. And also you have the Pro MR ring. So the Pro MR standing from monitoring. So you have the Pro ring with the phenolic insulation insulated for the second ring. And the aim for the second ring, which is an SGR ring, is to measure the shaft voltage. So when you install this ring, you know 24/7 what is the shaft voltage. And it's mostly used in power station, but also, you know, very sensitive application, like in wind turbine in the middle of the sea. So mainly offshore application. And then the Pro Max ring for more than a 400 millimeter shaft diameter. Like I said, 2-year extended warranty when you're installing AEGIS ring, respecting the best practice in the handbook. So you have 2-year extended warranty against bearing flooding damage. This is the application area we are evolving. So OEM, repair shops, steel mill, energy, wind turbine, pumps, compressor a lot, paper industry, automotive. This is not my area. I'm more in the industrial application, tooling machine and traction. And also more and more, we are present in marine industry with generators and turbo alternator. This is how ABB is using our device, placing on the motor frame cover inside, internal installation, placing the AEGIS ring from Baldor in NEMA standard. From VEG, bearing protection ring installed inside. VEG also is really forward thinking on this field, because they are proposing the AEGIS ring for EXD motors, so ATEX application, installing the AEGIS ring inside the flame-proof environment. So you now have the ability and possibility to order a motor with the AEGIS ring installed inside for a construction which is solid and strong, that can allow a sparking to happen. General Electric, you see, with the bolt-through application here. And this is all application OEM we are working with in Europe. So General Electric, Schneider, Sommer, TT Electric in France, and VEG in Portugal. This is one application area that I want to show with the permanent magnet generator. You can see the fiber that are touching the shaft here, and the high frequency grounding strap directly connected to the ring. Without any grounding, reach 20 to 29 volt peak to peak. And with the AEGIS ring grounding, we go below 1 volt, so 400 millivolts peak to peak. With the 800 kilowatt motor power, this is something I didn't mention, but you don't have any limit from the RPM side. So whatever RPM is, you can use the AEGIS ring. And you see, no grounding at all. You have around 15 volt peak to peak here. With the carbon block brushes only, you see you have high harmonics that are still passing. So 8 to 10 volt peak to peak. With the AEGIS grounding ring, shaft grounding ring, you see nothing. So 500 millivolts. This is why we say that carbon block brushes not working for high frequencies. Because of a lot of aspects. This is something that I can present in another presentation. Why AEGIS ring is the only tool that you should consider when you are dealing with high frequencies. So paper mills application here in Germany, 2009. You see this solution where they place the AEGIS ring here. This is for electrostatic discharge that could be very dangerous sometimes for the operator. So they decide, for the paper to insert the AEGIS ring here, because of paper dust and high humidity. Traction motor a lot. We are present pretty everywhere in Europe, here in Germany, here in TSA, so SGR ring. We are dropping from 30 volt peak to peak to below 5 volt peak to peak. This one in Belgium. This one in Stadler in Switzerland, where they install the AEGIS ring on the non-driver hand here. So you see, we drop from 35 volt peak to peak to 2 volt peak to peak here. In Škoda in Czech Republic, in the subway of New York. This is in Taiwan. And wind turbine application, quite a lot. We drop from 25 volt peak to peak without AEGIS ring to 3.3 volt peak to peak. 115 millimeter shaft diameter in split version, so in 2 parts, for 850 kilowatt generator. This one for 2 megawatt, dropping from 24 volt peak to peak to 2.17 volt peak to peak. So it's a Pro Max, so it's a shaft more than 400 millimeter. And this one you remember for offshore application, 8 megawatt, the Pro MR ring, to know exactly what is the level of shaft voltage. ArcelorMittal in Belgium. You can see a picture here of a damaged bearing of a steel mill. This one for ventilation system in Bremen in Germany. You can clearly see this is electrical fluiding. Spindles, so they have very high RPM, and they use also the AEGIS ring. We are talking about 50 to 70 kilowatt motor power. So only the use of AEGIS ring, no need of insulated bearing. The car that you see in front of you, they all have the AEGIS ring installed inside. We evaluate today 30 to 40% of the cars into the market, they have the AEGIS ring installed inside. Thank you very much. I was very happy to present you this our solution to the AEGIS shaft grounding ring to prevent your bearing failure. And this is our team in Europe, how we are organized. So we have 2 divisions, EV application. In Europe, we have Michael Fell in Germany and William Klock, and myself with Jens Leipner dealing with the industrial application. I'm the manager, like I said, in Southwest Europe, and my colleague Jens Leipner is more in charge for North of Europe. So thank you.
Sir, you are not going to